get started sooner than later. So the title of our talk today is on cross-site location jacking, or if you would prefer, XSLJ. And if you haven't picked up on it yet, this is a joke title. So to maybe give a more appropriate title, we can go to the next slide. So what we're really talking about are redirect issues. So we just thought it would be fun with all the interesting buzzwords that have been coming from the security community recently to see if we could tap into it a bit. So no, if you're wondering though, the actual topic of our talk will be redirects. So there's a lot of interesting things that go on with redirects, and part of the buzz has been related to OWASP adding open redirects as one of the issues to the OWASP top 10. So that's one of the things we'd like to address in our talk, but also kind of go beyond that and talk about some of the interesting and fun things that can happen with redirects. So to start with, I wanted to give an overview of just how redirects work. This is maybe a real basic introduction, but I figured it's best to start off so that we have a common base to go forward on. But before I get to the content, I guess I have a couple slides just about us. So my friend here who I'm presenting with is Eduardo Nava. You may know him online as Sir Dartcat. He has a lot of interests, one of which is making up absurd names for presentation titles. And I consider him the official manager of IBOS, which, if you haven't heard, is the International Buzzword Organization for Security. Please join if you would like. And he also, in his spare time, does a lot of hacking on anything made by Google or Microsoft. So fun stuff. As for me, I'm David Lindsay. I sometimes go by the name Thornmaker. I like lots of security things, but outside of security, I like movies, TV shows about serial killers, as long as they're likable. I like Finnish chocolate and salmon. And in terms of work, I work at Cigital. We have offices, a couple offices in Europe and then offices in the United States as well. And we're always hiring. I think it's always good to mention that. Okay, so moving on to actually redirects. So there's actually a lot of different ways that in a browser you can redirect a user. And I wanted to list a few of the different ways. So to begin with, you have what most people know as the 300 redirects. And so I've listed out them here. Some of them are more popular than others. 302 is pretty much the standard one to redirect a user to a different page. But there's several others that actually can work as well. So you can also use 300 status, 301, 302, 303, and 307. All of these have the end goal of that when the user clicks on a link, the response from the browser will include one of these and include a new destination for the user to arrive at. And that actual new destination arrives using the location header. So one of the headers in the response will say where the user can find the resource that they're looking for. So they request a particular resource. The response is, I don't have it, or one of the status messages saying it's not here, but here's where you can go look for it. That's the essence of what the redirect is. So it's nothing terribly complicated, but there are some simple restrictions. There's certain same origin policy issues at play, and various things to know about. So one of the interesting things here with location headers is that you can't redirect to JavaScript, URI schema, but with some of the other redirects that we'll talk about in a second, you can. So is that all the ways? Well, I already kind of gave this one away. No, there's lots of other ways to actually do redirects. So here's a few ways using the refresh header. So the syntax here is to specify some sort of time delay. In this case, the time delay is 0, meaning that you want the user to redirect instantly. And then you give a destination URL. So that's in effect is also doing a redirect, just like if you use one of the 300 status codes. And in this case, you can use it with the 200 status code in the browser, or there's actually quite a few other status codes that you can use this kind of a redirect with as well, 404 statuses, and we'll talk about later how you can easily enumerate which ones. Okay, so another way is kind of the same as the refresh, but doing it using a meta tag instead of the refresh tag. In terms of what the net result is, the end result is pretty much the same using a meta redirect. One interesting case to consider is what happens if there's multiple redirects if you have a location header and also use something like this kind of a refresh redirect, which one wins out? Well, in all the test cases that I tried with a few of the browsers, the location header always wins out. So it's just pretty standard that that trumps the location header. If you're doing a 300 type redirect, that will always trump over what's actually in the HTML content, which makes sense. So there's quite a few other kind of weird random ways you can do redirects, and these are all quite common. I don't know if officially these should be counted as redirects or not, but they're used for that purpose on a lot of pages, so I figured it's worth including. So I threw up a few of them here. This is by no means a comprehensive list, but just to give you an idea of some of the things that you see. So some of the more common ones are using JavaScript window.open or assigning something to the location.href variable. There's a few other kind of interesting ways. You can assign just something to location.port, and that will actually redirect the user to a different port on the same domain. And a few other location.whatever objects have a similar effect. And then there's a couple that are IE specific, and they're kind of interesting, especially for web obfuscation type attacks because they're not very well known. One is document.url, or if you happen to be an event handler, you can actually just use URL, which is quite nifty for various kinds of attacks. So those are a few of the different JavaScript ways you can do redirects. Oh, and then we have even more fun ones. So there's actually a lot of other technologies that you can have embedded in the browser that will allow you to do redirects. So here are a few additional ways. Flash has a few that I've listed here. There's more. You can use load bars, get URLs. PDFs are able to fire off a redirect. You can do it through Java applets or Java. Then you can have special URI handlers that are able to launch up, fire up a new application, which can include a new browser, which ends up loading a different page. So in a sense, that's like a redirect. And I'm sure that if we talked to people in the room here, we could come up with lots of other different ways. So anyways, that's just kind of a survey of the landscape in terms of what's available out there. So we'll talk about some different attacks or things that can be done with redirects here in a minute, but and some of them will be dependent on methods. For example, you might be able to use a refresh header but not another, or one attack might only work with location redirects but not others, but we'll try to highlight those as we get to them. So in terms of the issues with redirects, the kind of first primary one that comes to mind are open redirects. And this was an issue recently highlighted in the OWASP top 10 list that came out this year in 2010. So that's part of the reason why we thought it'd be interesting to talk about, though it's actually more of a coincidence at the end of the day than something that we're intentionally meaning. But we're happy to add some content to our talk relating to the OWASP, because I thought that was interesting that it was added to the top 10. So there's a link here to the top 10 if you're interested in seeing what it says. The kind of attack here is that an attacker is able to link to unvalidated redirects and trick the victim user into clicking on it. So I'm not for sure why the term unvalidated redirect comes in, but at the end of the day, it's, I guess, not too significant. I mean, what's important is that with an open redirect, the user is going to be able to do something like this, where you have some URL, and as part of the web application itself, it's going to include functionality that will allow the user to be redirected to another page. And then the problem comes in where an attacker can somehow control some of that content that controls what that destination URL is. So that in essence is what an open redirect is. So in this case, the attacker may want to trick a user into going to 0x.lv. That's our malicious domain for this talk. So if that's the case, then an attacker could construct a URL like this, and a user looking at this might see the beginning part, example.com, feel that that's a trusted site, so it's an OK link to click on, but then after the redirect occurs, end up on the attacker site. So it's a way for an attacker to do various attacks like phishing or to promote malware, and it's abusing the trust that a user has in one domain in order to get them to end up on a more malicious domain. Other way. Okay, so what are some of the other issues that we can talk about with open redirects? This is for you. Go ahead.
All right. So one of the problems is that some people try to consider if they are security problems or not. So in some cases, they are. So they enable phishing and malware attacks, so it makes them more easy for the user to click on those type of attacks, on those type of links. Like they will trust more a link that's on Google than a link that is on 0x.lb. Make browser plugin exploitable to some attacks, because plugins and browsers sometimes make mistakes and assume that, well, don't forget to consider about the fact there are redirects. And break trust on whitelist and URLs. So if you are whitelisting a URL for some resources, then if the URL is in a trusted hostname, but that trusted hostname redirects to some other website, then it creates problems. However, they are also not a security problem in some cases. If you take care of phishing and malware, that's kind of difficult. But well, if you kind of have a good whitelist of websites that are not going to redirect to other websites that are going to end up on malware, etc. If you decide to require the browser plugin to vendor to fix the vulnerabilities that may arise, like Java and Flash, for example, and if you decide not to trust and tell everyone not to trust your domain because it will have whitelists, and well, it's hard to like consider all these things. So well, anyways. So the conclusion is more or less they are a security problem. You have to remember that you have open redirects when you are writing code. So you have to remember not to use URL whitelists, and you have to rely that if there is like the next security problem that is going to be introduced because plugins and browsers forget that redirects exist. I don't know why. Well, you have to take that in mind. And you have to assume that all domains have open redirects, so you cannot use whitelists. And well, c'est la vie. So well, so are they useful? So they are useful. They are used to track user activity, like clicks on ads and clicks on search results. The ping attribute of the anchor element was supposed to solve this problem, but it didn't really work. And there are also handles complex session interaction, like logging in, logging out, note where the user is going to go back. If this is cross-domain, this is a more complicated problem. And there's also OpenID and OpenAuth that are kind of vulnerable by default to open redirects.
Before you go on, I just wanted to clarify one thing. So I think a lot of people might be of the mindset, and probably rightfully so, that open redirects are universally bad and should never be used. But if you look in the real world, there is actually many sites that do use them and justify them for various reasons. And so that's part of the reason why Eduardo felt and I felt it was important to kind of discuss, I guess, some of the rationalizations. Now, we had some of the rationalizations of why companies are doing this, knowing that they essentially are running open redirects. Now, we had a lot of discussion on how to word it on this slide, so this is kind of our compromise. But I just, if you're thinking, if you're a little bit shocked at the thought that, when would open redirects ever be acceptable or useful? Well, there are companies that do that and have legitimate reasons, and so this is just basically presenting what some of those reasons are. Whether you agree with it or not, I mean, this is what some companies are actually doing. So, sorry, go ahead.
Right. And to interrupt modified navigation flow, and this is a good example in the hotels and Wi-Fi airports, for example, that they use redirect to the original page and they put it in a request, right? So there are several solutions that are attempted, like signing and encrypting the URL to redirect. So this is easily to circumvent, like if you can make the website to sign your URL. So, well, like if the victim website is signing URLs for ads, then you can just create an ad, and then you have your redirect, like it's semi-automated. And check the URL and verify who it belongs to. But, well, that's a problem because you have to first realize that the website that you are redirecting to, even if it's some trusted one, may have a redirect. And if it doesn't have a redirect, then you may have problems with parsing the URL. And that's what I'm going to talk about right now. So URL parsing. URL parsing is quite difficult. This is something that was fixed some time ago and was found by a friend. And anyways, the problem was that we were whitelisting the host names that we were redirecting to. And anyway, so we have evil.com, and it will return an error. It will say to the user, hey, you're going out of Google. If you go to google.com, then it's OK, who cares? But if you go to http with 3 slashes evil.com, then it will also be OK. The reason is because